Hello everyone, this is Rakesh Kumar from Chandigarh Polytechnic College. Today in this video lecture, we are going to discuss about the serial port operation of 8051 microcontroller. Actually, first of all, we will discuss the parallel communication that occurs in 8051. The microcontroller can communicate data in either parallel form or in serial form. In parallel communication, data is transferred parallelly. As you can see in this image, the data from the sender is going towards the receiver end, and this transmission is the parallel communication, because in parallel communication we use a single medium or a wire for each bit that has to be transmitted from sender to a receiver. As you can see here, 0 1 1 0 0 0 1 0, these are the 8 bits, and we have to send it up to the receiver. For this each bit, we have to use a single wire to transmit it parallelly from sender to receiver. On the other hand, in serial communication, which is opposite to the parallel one, the data is transferred in bit by bit manner over a single wire. As you can see in this image, this is the parallel communication of 8051 that occurs from sender to receiver or transmitter to receiver. And for this, we need 8 lines to transmit 8-bit data, and each bit has to be transmitted individually on a single wire, single line, or you can say single channel. This is the serial transmission of data. Here figure shows the serial communication. In serial communication, parallel to serial converter and serial to parallel converter module is required. For this type of communication, that is the serial type of communication, we need a parallel to serial converter at the transmitter end and its opposite at receiver end, that is the serial to parallel converter at receiver. And this function we can take from the UART, that is the universal asynchronous receiver transmitter. It performs both parallel to serial and serial to parallel conversion. In 8051, we know that inbuilt UART is available that performs the job of serial communication of data. As you can see in this image, the sender has to transmit 8-bit data 0, 1, 1, 0, 0, 0, 1, 0. This is the 8-bit data. And first of all, we have to convert this parallel data into the serial data so that all the serial bits can be transmitted over a single wire, single channel up to the receiver end. And when a receiver receives the serial data, then again it has to be converted into its parallel form. Actually, in serial communication operation, we transmit 8-bit data bit after bit in a serial manner, as you can see, over a single wire line. In this, only a single medium has to be used. In this image, you can see for each bit, one line is used individually, but in this, the channel is one, the line is one, over which bits have to be transmitted one after another. This is the serial communication operation. Now we will discuss the serial buffer register, that is the SBUF. Its main function is to store the transmitted data before the transmission and to store the received data before receiving up to the receiver end. It is an 8-bit register and is used for serial communication of data in 8051 microcontroller. Whatever data is required to be transmitted by a TXT line in 8051 must be placed in the SBUF register. Before transmission, the data has to be placed in SBUF register. Similarly, at the receiver end, the received data via RxD line is saved in SBUF register. When data is written to SBUF register, then it is framed in between start and stop bit. Before transmission, we have to frame our transmitted data that has to be transmitted. We use here start and stop bit before sending the data to the receiver. Similarly, during reception of data, start and stop bits are removed so that actual data that has to be transmitted in between the start and stop bit can be received, and then it is placed in the SBUF register. You can see the start and stop bit. The data bits are placed in between both of these start and stop bit. This is the function of SBUF register, that before transmission, the data has to be stored in serial buffer register, SBUF register, and before transmission, again the data has to be stored in the SBUF register so that start and stop bits can be removed and actual data that is actually needed can be extracted from the transmitted data. Next is the SCON register, that is the serial control register. It actually controls the operation of the serial port. The serial ports can be used either transmitting mode or reception mode, because serial port in 8051 is the port where we have to transmit the data and also have to receive the data. The interrupt status for the transmission is provided by TI, that is the transmit interrupt, and status of the reception is provided by the RI, that is the reception interrupt. These are two bits of SCON, that is the serial control register. This is also a bit addressable special function register. Bit addressable here means we can change its 8 bits according to the operation. The serial controller SCON special function register is used to control the 8051 microcontroller serial port operation. Using SCON, you can control the operation modes of the serial port, baud rate that has to be sent by a serial communication, and send or receive data using serial port. Below you can see the serial control register, SCON register, that is of 8-bit in size from D0 to D7. You can see RI is the receive interrupt, TI is the T transmission interrupt, RB8, TB8, REN, SM01 and 2. We will discuss one by one in the next slides. You can see here SM0, SM1 and SM2. These are the serial port mode selector bit. Mode selector bit here means that the serial port, in which mode the serial port have to operate. SM0 is the SCOM's 7th bit and SM1 is the SCOM's 6th bit, and these are used to select the mode for the serial port operation. SM2 is not used for 8051. We can use this SM2 in 8052 because it has two timer serial ports. REN is the receive enable. To enable or disable the reception, we have to set or reset this pin accordingly. REN, that is the receive enable, Before reception, you have to enable this bit, that is the REN bit, that is the number 4 of SCON. TB8 is the ninth data bit transmitted in mode 2 and 3 of the serial port operation. Ninth bit is the stop bit after the data, when the data bits have finished, the ninth bit, that is the stop bit, has started. And TB8 is the ninth bit in transmitted mode 2 and 3. Same is the RB8, that is the ninth data bit received in mode 2 and 3. TI is the transmit interrupt flag and RI is the receive interrupt flag. In this slide, you can see SM0 and SM1. We will discuss all these bits in detail again. SM0, SM1, these are the mode selector bit. These two bits of SCON register actually determine the framing of data by specifying the number of bits per character and start and stop bits. There are four serial modes because SM0 and SM1, these are the two bits, and according to the two bits we have four combination, that is the 00, 01, 10 and 11. And accordingly the serial port operates in mode 0 if both of these bits are 0. Mode 1 is after SM is 0 and SM1 is 1, and mode 2 for SM0 is equal to 1 and SM1 is equal to 0, and serial port operates in mode 3 when both of these bits, that is the SM0 and SM1, will be equal to 1. If serial port will operate in mode 0, then it acts like a shift register. It means that the data is sent bit after bit and baud rate in this case is variable. And when SM0 is equal to 0 and SM1 is equal to 1, then the serial port operates in mode 1 and it acts like a 8-bit UART, and in this case baud rate is also variable. And when serial port operates in mode 2 and 3, here we will use ninth bit along with the 8-bit data, and in mode 2 the baud rate is fixed and in mode 3 the baud rate is variable. The ninth bit, you can see here, the ninth bit is used only in mode 2 and mode 3, and for mode 2 the baud rate will be the fixed and mode 3 the baud rate will be variable. Next is the REN bit, that is the receive enable bit. When it is high, it allows the 8051 to receive data on the RXT, that is the receive pin. So the receive and transfer data REN must be set to 1. When REN is equal to 0, the receiver will be disabled in this case. If you want 8051 to receive the data, then you have to make this pin REN equal to 1. This is achieved as below. To set the REN pin equal to 1, you have to write the command set bit, that is the set b as con dot 4, and to make this pin is equal to 0, you have to clear this bit by using the instruction clr as con dot 4. Next is the TI and RI, that is the transmit interrupt and the receive interrupt. When 8051 finishes the transfer of 8-bit character, it raises the TI flags that indicate that it is ready to transfer another next byte. This is the, you can say it is the indication signal that indicate it has transferred the 8-bit character and now it is again ready to take transfer of another byte, that is the 8-bit. The TI bit is raised at the beginning of the stop bit after the data. Now receive interrupt, when the 8051 receives data serially via RxD, it gets rid of the start and stop bits, because here we have to remove the start and stop bits to extract the data and places the byte in the SBUF register, that is the actual data that we have extracted from this. Then it raises the RI flag bit to indicate that a byte has been received and should be picked up before it is lost. This is all about the serial port operation that we have discussed in this video lecture. Firstly, you have to understand the parallel communication, where for each and every bit you will use single wire line to transmit the data from sender to receiver, and opposite it is the serial communication, which uses only single medium to transmit 8 bits bit after bit. And before that operation we have to convert the parallel data into serial mode, and after, when data received at the receiver, this serial data has to be converted again into the parallel form, and this conversion from parallel to serial at the transmitter and serial to parallel at the receiver is achieved by UART, that is the universal asynchronous receiver transmitter. Then again comes the SBUF register function that attach the start and stop bits at the transmitting end and remove the start and stop bit at the receiving end. This is the main function of SBUF register. Next is the SCON register, which is the 8-bit in size. It actually controls the serial port operation. In this, the two bits SM0, SM1 decides the mode of serial port operation, in which mode the serial port has to be operate. REN bit is to receive the data by making the this pen equal to 1. If you will make REN equal to 0, then the receiver will be disabled, and it is achieved by using two instructions: set bit scon.4 and clear scon.4. Next is the TI and RI, that is the transmit interrupt and receive interrupt. The TI bit is raised at the beginning of the stop bit, and the received bit interrupt is raised as the RI flag bit to indicate that a byte has been received and should be picked up before it is lost. This is all about the serial port operation of 8051. Thank you.